So, good evening, everybody. Welcome
Hello.
to our webinar. I'm Spiros. Nice to meet you, and welcome again to another webinar of our company. And today also we have our partner exocad, and also my good colleague and friend Michael Cohen. Michael, you can talk if you would like.
Yeah, greetings from Luxembourg. I'm actually here in the exocad Benelux office. Yeah, my name is Mikey Conan. Thank you for being invited here for this webinar. So I'm the Global Application Support Manager. It's a long title, but short meaning. So it means I'm the head of the Global Application Support. Yeah, and I've been invited by Spirus to follow this webinar. And yeah, I'm a master dental technician for almost 25 years now. And I work for exocad since 2014, and I work with exocad since 2009. Yeah.
So, for those that they don't know me, I'm a dental technician too. I'm working for Medit. I'm technical trainer for the region of EMEA. I'm responsible for the technical training of the partners of Medit and also for technical support through our platform. So today, what we're going to show you, what we're going to talk about today. So first of all, I will show you in the presentation that I have prepared for you the workflow. Basically, I will describe you the whole workflow, how we start, how we scan, and how we send the files from a clinic account to the lab account. And then you can proceed to the design. And then Michael will take the wheel and he will explain you also by using exocad share site, what you can do, how you can do it, how easy you can do it, and things that you can do with that. So Michael, you can take the wheel starting from your
Okay.
presentation. And also apart from Michael's small presentation, apart from mine, in the end, Michael will have a live demonstration of the exocad share site. So people sit back, relax, and enjoy the view. Michael, it's your own.
Okay, and thank you for the introduction. Yeah, last week I discussed with Spirus which product, dental CAD or chairside CAD, to be shown today. Well, as the webinar shows how to scan with an intraoral scanner, for me the answer was quite clear. Therefore, today I'd like to take the opportunity with a very challenging case to demonstrate the possibilities with exocad chairside CAD. Some of you might think chairside is a slimmed down version of dental CAD, but in fact, that's not true. So today, I try to prove the opposite. We have invested great efforts in automating processes, and we predefine parameters to reduce manual rework to a minimum. It's a fully functional CAD software. Oh, yes. What's that? It's a fully functional CAD software, but tailored to the needs of clinicians. Yeah, next slide. Sorry. With Matera's core version, we provide a solution for single visit indications like single crowns, bridges, veneers, and inlays. To offer an out-of-the-box product adapted to the market, our R&D and integration team is working constantly on integrating materials, libraries, and hardware. Matera comes with 5 new add-on modules, making chairside CAD a full-featured high-performance design software. So the new modules are the implant module, the model creator, the jaw motion module, the smile creator, and the DICOM viewer. So actually today with exocad chairside CAD Matera, you are able to do all kind of implant restorations. You can create models, you can design splints, you can design provisionals, you can do smile planning, you can use the auto articulator to improve occlusion adaptation of your restorations. The same for jaw motion import. You can import DICOM viewer or use the True Smile module as a visualization helper. And quite interesting tool as well is the InCAD nesting module, which allows you to place the restoration already in the blank, or let's say here it's quite different. You place the blank on the restoration to make sure that the layering corresponds to the desired layering in your restoration. Medit i500 integration is done through the Medit Link software. CAD design can be done on the same PC. The dental CAD can be started directly from the Medit Link software. Using a Medit scanner, there are two options to communicate with your partners, for example, with your lab or with a milling center. You can send it to registered Medit users through the Medit Link software, or in case you have installed the Dental DB, you can use exocad's own collaboration tool, the Dental Share. I will shortly also show how this does look like today. And yeah, that's it. So from my side, let's see how this looks in real life in cooperation with the Medit scanner.
So thank you, Michael. So now I will start to describe and show you all step by step for the case that we have prepared today with Michael, which is a 3-unit bridge and 2 implant crowns.
2 screw-retained crowns, yes.
2 screw-retained crowns, yes. So I would like to show you everything that we will start from scanning, and then we'll proceed to to the clinic account for the post-processing, then send the files to the lab account, and then Michael will finish with the live design. So, okay, let's proceed now with the whole description. Let's begin.
So here is the case that we're going to discuss, me and Michael will proceed with the design. So what we have here is just a 3-unit bridge with 2 preparations and 1 ponding, and also 2 implant crowns on the lower jaw. I have scanned only the upper jaw and the lower jaw just to save time, and of course the occlusion. But I have skipped some very important steps that I'm going to show you right now. So let's proceed to the scanning. I have clicked scan, and now the system will jump on Medit iScan. So, before I scan, let's change the music of the scanning because it's the classic music, the classic sound of scanning. So I would like to put something more positive. I think we all have this need or this period. So I will change with a 90s song that maybe most of you know. And now, let's go now here. I have upper jaw, the lower jaw, and of course also the occlusion. Here and here. So far so good. So what I do first, I will switch on texture because this is what I need to do. I will take my polyline, I will just cut only the preparations, nothing more than that. And I will proceed to scanning. I switch to texture in order for me to see the area that I'm scanning with high definition. I click my scanning button in order to exit the trimming tools. I activate now in the bottom of the screen a high definition, and now I will start scanning. So, here we can just check with the reliability map and see if our scanning data is okay. So here is perfect. Okay, we don't need to insist more than that. And now we're going to proceed to the next step here, which is to do the scan body matching. So now what I'm going to do is that I'm going to do the scanning of the scan bodies. Keep in mind two things only. Always we scan with the healing abutments on position first when we are scanning the jaws. Then we will activate normally, in a real case in the mouth, the white light. We will switch the scanning depth on 21 millimeters, and then we'll start first scanning the emergence profile. After we cut, of course, the areas that we have the healing abutments. After that, when we will jump to this step that we are now, in order to scan the scan bodies here, what we should do is that we need to activate the high definition scanning, okay, or high resolution, and of course I'm going to use the scan body matching in order for us to see how we can use it. So let me prepare my scan bodies first. So now here we are ready to scan the scan bodies. So let's go step by step. In the real mouth, I will just first release the healing abutments with activated the white scanning light and the scanning depth on 21 millimeters. I would scan my emergence profile. Okay, I would use the lock area with the brush to just lock only the walls, the internal walls of the emergence profile, nothing else. Okay, and then I will put the scan body with high definition. I will scan it and lock it, all of it, before I proceed to the next step. In case you have a situation like that here, that you have one implant after the other, always make sure before you proceed to the next one, especially if you have one scan body only, to lock first with the lock area your first scan body scan and then perform the next one. So here I don't need to do that, so I will just press my minus here. I will paint again and I will disappear that. So let's begin. So I will just minimize here my scanning depth. I don't need to be like that. And I have performed my scan already, so I'm here in the scan body. Okay, what I will do first, I will select my scan bodies. I have clicked my scan body matching. Okay, I have activated here my deviation map, which is on the left. Okay, I'm going now to select my library. So the library I'm going to use is the following one from Tentium, and specifically this one. In case I would like to set it as a favorite for the next time, I will just click here. I will leave this like that, or you can give any other name you want and click confirm. So I will select the two that I'm going to scan, which will be the 36 first, and I will click assign. Okay, I'm doing one by one in order for you to see the process. So I start scanning. And I check here on the bottom. I need to activate the high definition. Always we scan with high definition our scan bodies because we need detail. Okay. Again, I mentioned that high definition means that I scan with higher detail, not with higher accuracy. Don't confuse that. Okay. The accuracy of the scanning depends on your technique, on the way that you're scanning. It doesn't depend if you're scanning with standard definition or high definition. The high definition, standard definition has to do with the triangles that we create. So the smaller the triangles, which happens in high definition, the higher the detail that we will capture the data. Okay. So everything is ready, and now we're going to scan with our scan body. I begin. You need to make sure that your data are captured all around the scan body in the best way possible. From all sides. Okay, you see now that the alignment is done. Okay, But in case the alignment was performed earlier than that, never stop the scanning. Keep scanning until the end, until you have captured perfectly all the scan body all around, because your dental technician needs every single detail. The more details you have, the better. Okay, so please pay attention not to skip any information from your dental technician. Okay, I will just cut only this small data. I don't need that. Okay. And now we're going to proceed to the next scan body, which is the 37. I click 37, I press my library, and as you will see, I'll go now directly on favorites. I will select my favorite already, I don't need to perform again the same step. 37, assign, confirm. But of course, as I said, before we proceed, even if we have both scan bodies here, always I recommend to everybody to lock the first scan body scan to be safe, always. And now we are going to scan safely the next scan body that I have here. So I exit from the lock area and I'm going now to scan my scan body. I check again, I activate the high definition. Okay, and I'm going to scan. You pay attention on the live view to see clear the surface of the scan body. This is crucial. I don't stop here, I insist more. As much as I can. Okay, so here you see I have my alignment also here, and you see all around is perfect. Okay, so now I don't need to lock anything else here because I finished my scan. Okay, and what I will do now is that I will only click complete in order to perform my post-processing of the case. I press complete. And here, what you have to select, if you're going to send the case to your lab, you select the first option here, the create standard digital model. If you're going to print in-house for some reason the scans that you have performed, you will select the 3D printable model. Okay, but please keep in mind that it's far better in order to do that through in case, of course, you need to set parameters and you need to have analogs, etc., etc., etc. So, in case you want just to print something simple, you will select create 3D printable model. Otherwise, if you want just to send the data to your lab, you will select this one. And this one, what I will select also. And now the post-processing will take on. Okay, I go now to the case folder. Now the Medit scan will close, and now we will start here the post-processing. Here we are. The post-processing time depends on two things. First, the size of the data. Second, the resolution of the scanning. Okay, so if you scan with high resolution, always takes a bit more time to do the post-processing. If you scan with standard definition, you don't have to worry because it takes less time. And of course, the parameter that we always consider that is already preset is that you use a laptop or a desktop that has the specifications that we recommend also on our help center. So here the post-processing is finished. as you see. Now if you would like, you can export instantly and locally in your desktop the whole case, but I'm not going to do that here. So, in order for us to send the case through Medit link to our lab, first we need to make sure that all the files are uploaded on the cloud. So it would be very nice to check before you do this protocol and see if your upload speed is quite sufficient. Okay, what I would like to discuss here, I would like first to discuss this. I have this case that was uploaded on one of our Facebook groups much time ago, and has 3 implants. What you need to know here is that when you're going to scan an implant case, always you need to make sure that this area here, the flat surface, should always look on the buccal side. Okay, this is the first step. The second step that you should have in mind is that you need to make sure that you have sufficient space between the implants in order to scan perfectly all the sides of the scan bodies. So sometimes maybe it is a bit better and more convenient for you to scan with less scan bodies than the number of the implants, because you will have a sufficient distance between these two in order to rotate your scanner and put the head here. So it will cover this area or this area, or basically any area you want, because you will have the space here. Okay. In a case like that, as you can see, the space here is very small. So many of you would think that, okay, maybe it's better to take all the scan bodies in order to finish faster. Okay, but most of the times it won't be that beneficial as you might think. Okay, so please make sure to see with your with your eyes that you have sufficient space in order to rotate inside here the scanner with the scan bodies. The scanner in order to scan the scan bodies. Okay, and let's go now to see other 2 things that you can do. In the latest version of Medit link, we have provided you 2 ways to communicate. The one communication is with your patient, and the other communication is with the lab. So with the lab, what you will do is that you will come here on the share button, you will click the share, you will select what you would like to share with your lab, and I will just unselect some information. I don't need all of that. Let's say I need only this. You have only the limitation of 200 megabytes in order to be shared to all mobile devices. You click get to receive the link, and now you can send it either by email from here, from this icon. You see the expiration date. Okay, it's 1 month. So you can send it either with email, or you can copy on any messenger or Skype or whatever. Okay, and since your lab would like to see that, they need just only one thing, just internet, nothing else. They don't need to have necessarily a lab account on Medit link in order to see the link that you're going to send them. Okay, but of course, in order to receive the case through Medit link, they should have, of course, in advance a lab account on Medit link. And of course, it's not mandatory, and they don't need to have necessarily a Medit scanner in order to have an account. They can create anytime and they will be able to use it. So let's say that I'm the lab and I open this link. So now you will see that we will load the files. What you can do here, the first thing that you can do is that you can leave annotation with this icon here. Sorry, here, this one. So let's begin. Annotation, this one. I click annotation. I can put whatever I want here. I just click OK. Okay, and then I will just click, let's say here, and I will leave my annotation for the lab. It can be anything. Okay, so you click OK, and since you set that to the lab, when the lab will open the link and they will click on it, they will see your annotation here. Of course, if you are live, they can reply on you and you can start the chatting here below. So with this button, in case you are live, you can also select here in the upper right corner the live button, so you can communicate in the same time, both of you, with your lab. Okay, and you can discuss the case. This is the one way of communication that we have through Medit link. Let's go now to the other side. The other side now is the communication with the patient. Okay, so if you would like to send him your scan data in order to discuss the case and what you can do with that, okay, what you will do, you will click here on the lower left corner on meditlink.com. This will guide you to Meditlink web page, which is your account here, okay? And now I will come here on the case talk and I will find my case, which is here, as you can see. I will click share. Here I can select again the files that I want to share with my patient. Okay, certainly I need to select to deselect the occlusion file. I don't need the occlusion file, and I don't need the library info. So I will share 10 megabytes with my patient. So click share. And now this is another important crucial point. As you know, we share data that belong to the patient, so they have to be safe. So what we do about that? In case, let's say, something by mistake will receive the link, it's not enough. So what we do is that we generate also a PIN code that you need to send to your patient. Otherwise, if somebody will get the link, he won't be able to open the scan data of the patient. So I click details. And now I will go here which says case information. I will click it and you will see that here we generate the PIN code. So to your patient you will send first the URL, the link that is here. He doesn't need to have anything special, he doesn't need to download anything at all. He will just receive the link and he will click on it and then he will insert the PIN code that you see here. So if you don't send the PIN code, you won't be able to see the link. Okay, so the link is here. Let me go again. So you on the case talk you have press share and then you come here on the case information and here is your PIN. So now let's say that you would like to send all this information. You go to web viewer, and of course you will go here, and from here what you can do is that you can write the email address of your patient and the comments and send to him. You can generate a QR code, and of course here you see the link, the PIN code also, and of course you can send the link directly to his mobile phone by writing his mobile phone and click share through our system. So we ensure that you have communication both with your patient to discuss the case and also with your lab from both sides. The difference between these two is that for the share of the data to the patient, we generate also a PIN code for maximum safety of the data. Okay, so even the patient who will receive it, we should be sure that it's everything safe from our side when we share the data with him. Okay, so now what I'm going to do, I'm going back on my case folder here. I'm going now to share my case with the lab. Before we do that, let's show 1-2 tools that you can do. So for example, let's say that we are here. Okay, another tool that you can share with your lab and do your stuff is this one here. So you can go here on the image capture in Memo. I can take a picture from here, and here I can take my pencil or brass, whatever. Okay, and you can, let's say, divide the tooth in 3 segments if you would like. Okay, and on the text, selecting here, you can write here the colors in case you would like a multi-layer. Yes, that's also another amazing feature that you can do. So your lab will know what you prefer in a multi-layer. And here you are. Of course, you can do the same. I click save, and now this data will be generated and saved in my case folder. So if I press here, you will see it. Okay? And also, another important thing, in case you would like to do it, in case you will check your data and let's say that you have any kind of holes, here we don't have any holes, it's perfect, our scanning, you always go here on the fill hole, you will click it, and now you will see by changing here the hole parameter, okay, if I click fill hole, if I had any holes, it will click, fill the holes that I have on my scan data. Keep in mind also that this tool can be used not only for the data that we generate from the scanning software, but also for the files that you import in our system and that you would like to share with your lab. So, in case you use the attach button here, okay, and you import another file, any kind of file, for example an STL, OBJ or PLY, and has some holes, you can close the holes on that by using the same tool here. So you will click on the attached file and then you will click fill hole, so you will be able to close the holes also from that file. Okay, so now let's send the case to the lab. I click order. There are 2 ways to send. The one is the contract, which is this one. Okay, so with the contract we can perform payments through Medit link. I'm not going to do that now. I'd say, okay, I'm just going to send the case directly to my lab. Okay, the prices are typical. It's just for example, for demonstration purposes. Okay, if you go here like that and click skip payment, you send directly all the files to the lab. But even here, if you go to file for order, you can also select which kind of files you would like to share with your lab. So in case I want to share them all, I keep it like that. I have my lab already. This is my lab account, and please pay attention here on the share patient name, because by default we share the patient name. So if you don't want that to happen, you just untick this box here. Okay, and you see here, after the scan body matching, we transfer instantly to our lab the scan body libraries that we used. So I click skip payment, and now the case is sent directly to the lab. As you see now, my case became ordered. And if I come here to my order box, you will see that my case is pending here. You see? So now what I'm going to do is that I'm going now to log out from my clinic account, and now I'm going to log in to my lab account in order to proceed from there. Before I proceed, just to mention you here that in upper right corner you can print the prescription of your order, either with a PDF format or by a physical document in your document printer in your office, in case you would like to keep it in printed form. You can see it here. Okay? These are the 2 options that we have. So let's now log out, and I'm going now to log in to my lab account. So now, as you can see, I logged in my lab account. Okay, I'm in the inbox. I click the pending order, and also again on the upper right corner I can print the prescription. okay, as a lab now. Here you can see in the memo for order the information about the implant libraries that I used. Okay, and also now in order to proceed, I have to confirm the order. So I click confirm order. And now the case is going straight to the workbox. So I click here on the workbox. I will go here. If you notice that the patient name is not shared, you see that here. And now we are in the phase that we can proceed to the design. So if you have already installed exocad in your computer, in the same computer with Medit link, and that you have your lab account, and then by, of course, in advance, we have make sure that here in the settling program, you have select exocad as your default CAD program, okay? And of course, in case you use any of our scanning softwares, you can use them, either one of them or both of them. It's up to you, there's no issue. But specifically for the CAD program, you have already the option of exocad. So make sure that when you do a new setup and a new installation of Medit link and exocad, make sure that first we have installed exocad in the computer. So when you install Medit link then, or even Colab first, okay, instantly our softwares will, first of all, Medit link will find that you have already exocad in your computer. So you will just need to make sure that it's already ticked here, okay, and you will click apply. And Colab will ask you if you would like to integrate with exocad, okay, in order to be done automatically. So I click apply. Again, you click apply here, okay. And now you can check the files here in case you want or something you don't like. Here you can see our scan bodies, okay. This is also the pictures that we had before, okay. So now it's the time that if we press CAD, automatically we jump on exocad dental CAD, and now it is the moment that I leave the wheel from my side, and now Michael will take the wheel and proceed to the design of this case that we are going to discuss. So Michael, you take the wheel from now on, and you can proceed with your with the design in exocad dental CAD.
Okay, yeah, thank you. Let's share my screen. Okay. Yeah, so as I already said, there's a second option to communicate with your partner. So if you like to work directly with the exocad, you can do that with the dental share. I will not go into detail today. Yeah, but that's how it looks like if you get the case sent through the dental share. Note also that projects from Medit are compatible and can be imported into the Dental DB. So what you see here is actually our Dental DB. And if you get a case through the dental share, you'll be informed in the system tray, and then you have to accept it. So that's what I do now. I accept now, and my partner, he can see now that I accepted the case. And when I finish the design, he will see that I do the design. If I finish the production, I can confirm that the production has been done. And if I do the shipment, I can even add a link for the tracking of UPS or else. Okay, so now we have the case here in our Dental DB. So as I already said, it's a challenging case, but not impossible. Let's say with challenging, I mean it's not really a typical single visit case, because we have here a 3-element bridge and 2 screw-retained crowns. So I've selected therefore here for the screw-retained crowns a kind of composite material to create, let's say, provisional screw-retained crowns on my implants. And for my 3-element bridge, I've selected a multi-layer zirconia. then we can go to the design. I start the design software directly here from the action button in the Dental DB. Then the dental cut application will be started. That's the second application. And yeah, in the first step, if the scan data orientation is unknown, you'll be prompted to correct this. This is quite easy, so it's very intuitive. If you see it from below, it's red, and this means it's not correct, and it's explained here in the window. You simply rotate it in a way that you can look from the occlusal side, then you say set current viewer axis, and then you go to the next step. Just some basic information about the software. So you are guided through the entire workflow with a wizard, which you can see here on the left side of your screen. On the top left, you can see a show height window, which allows you to show or hide different meshes of your job. And here on the right side, you can see some options and tools. So for the experts, I will show that in the next step. You can also close the wizard and go into expert mode, which gives you much more possibilities for the job. Okay, first step now here is on the lower jaw, we start with the emergence profile of our implants. But before I do that, I will just show you one of our expert tools. So to do that, I just quit the wizard. Then I go to my expert bar. Oh no, I go directly to the scan. I choose right. I click the right mouse and then I choose edit meshes. I can do that, for example, if you see here that your scan has a lot of artifacts, and sometimes I prefer to crop the scan. It makes it easier to work with it for the visualization. So you have different options. You can select straight through or just the surface, or you can just click on the surface to select the entire mesh. So let's do it like this and then select the area to be deleted or cropped. So if I click crop now, for example, I keep the yellow area. If I click delete, I will delete this part. Then let's delete that and edit mesh on the lower jaw. Let's do the same here. Okay. And then I would also like to show that you can easily, for example, close a hole. For example, if there's a hole, just mark the area around the hole. Then, oh, sorry, that I clicked on crop. Then you simply click on close holes. And with oh, yeah, now it closed everything. So, but I can even undo that. Let's do that again. Okay, let's do a hole, then close the hole like that. And now we can even delete again part of the mesh like this. And okay, let's go back to the wizard. We can also add, for example, custom views here. You see that you have also some arrows to choose different view angles of your reconstruction, or you can even create your own one by selecting the desired view. Then you can add a custom view. You can even rename it, for example, buccal. You can update it from a different view. You can add a series of different views and so on. To show and hide the different meshes, you can use the show hide window, or you can use our hotkeys, which are well explained on our mouse pads. And I'll explain that later. Okay, in the first step, emergence profile. Compared to the lab version, this will automatically start in the draw tab here. But we can, yeah, let's do the 37 manually, and you simply draw the emergence profile border. And then on the 36, we will do the automatic detection. Okay, you can still do changes here. And let's go to the 36 and try the automatic detection, which will obviously not work perfectly here in this case because this edge is quite thick. Yeah, you see, but you can easily add additional points to help the algorithms to find the area you'd like it to be detected. Okay, don't be too critical here, because in the next step you can see that in the emergence profile step you can still adjust the emergence profile border, and I prefer to do the details in that step. Then we proceed. Yeah, now we go to the upper jaw. This is a cement retained restoration. Of course, then we have to detect the margin. It's also possible to detect the margin already in the scan software. If you do that, it will be automatically transferred to the CAD software, and this step will automatically be skipped. The same for the registration of the scan bodies. Maybe you figured out that we didn't do any registration here because this has been done in the scanning software. And if you have this opportunity to do that in the scan software, I'd recommend to do that, because most of scan software on the market are able to do the registration with the point cloud before it will be triangulated. And it might be that then the accuracy is higher. I don't want to say that the accuracy of our registration is not good, but if you have a scan software which is able to do that, you can do it there. Okay, on tools 25, we do it with the automatic detection. In the settings of the software, you can also define if you want a margin line detection step to be started with the detect or the correct draw tab. By default, it's set on automatical. And yeah, now we can see that we can detect it with the automatic algorithm. So yeah, that's what I thought. On this case, it will not be detected maybe perfectly. Normally, in 95% of the cases, the algorithm works perfectly. You have to know with intraoral scan, it's maybe quite difficult. If you have a prepared or ditched model, then of course the algorithms work much better. It's quite easier for them to detect the margin line. So, and here you have also to take a decision. For example, in an intraoral scan, it might happen that you have a subgingival preparation type, so which means that your preparation is below the gingiva. Then you should use different algorithms to detect the margin. Then you can click here on this button, and it will change the mode of detection. Then you have also to define 4 points, and then the software will search for these concave areas to detect the margin line. I will not show that now because it will obviously not work with that case. So in any case, if the detection does not work correctly, you can, as I did, add additional points, or you go simply to the correct draw. And here you have even the ability, instead of just correcting the points, you can even draw part of the line. So this is the additional line in blue. With a double click, you finish. And then you have a new detection of your margin line here in this area. You see on the top right of the screen, you see a profile view, which you can enable or disable here with this button. And it's a kind of cut view, which is placed exactly on the position of your cursor. And it might help you to find the best point or the best area to place the first point of your margin line detection. Okay, let's go to the next step. Here we will again try to do an automatic detection, and I think on this, yeah, you see perfectly detected, and then let's go directly to the next step. Yeah, so insertion direction, big chapter, important chapter in in digital dentistry as well as in the analog technique. Compared to the lab version in 5-axis mode will automatically detect the insertion axis, and you will only be prompted to verify it if the software thinks that there's a problem. But here in the chairside cut, the software will always ask you to verify the insertion direction. I prefer that feature. You can also configure your lab version in a way that it will always ask you to verify the insertion axis. Yeah, then in 5-axis mode, we do an individual insertion for every tooth. If it's a case with bad preparation or divergent dies, then I would recommend to choose here a unique insertion direction, which means that you choose just one insertion for the entire bridge. Then you define insertion, you click on the button, set current view, and then you proceed to the next step. Now the software will create the crown bottoms. It created the crown bottoms, which means the cement gaps and the minimum thickness. And maybe you figured out, or those who know the lab version, that this had been skipped here in this software. So the aim is to automate some steps and to make the dentist's life much easier. I don't think that any dentist want to play with parameters. That's why we are always trying to provide an out-of-the-box product. And as I already said here in the beginning, if you choose the correct material, which can be provided by your manufacturing provider or by your milling center or whatever, they can give you a work params file which comes with all the materials they provide with the recommended parameters. Then you don't need to do anything here in this step. Of course, you can go into the expert mode, or you can change parameters here in the beginning. But compared to the lab version, you have a step where you can verify the steps again. But here it is simply skipped. Okay, now this is now a very interesting step. So now we can see how I use my hotkeys. For example, to hide the entire upper arch, I hit X, like maxillary, or N for the lower arch, mandibulary, and it would hide not just only the skin, but also all the parts of the reconstruction. Yeah, and here's a nice tool. You can also skip that tool. If you just want to work with library teeth, then you can skip that tool. But here on the lower jaw, I'd like to show it. Here you can mirror or copy the morphology of the patient. So let's decide that we want to mirror the 46. You click on the tooth, and then you place it here on the 36. Then we simply say copy mirror another tooth. We do it again on the 47. And then you place it here on the 37. The software automatically detects where you place it. So if, for example, if you place it on the minimum thickness of a tooth 25, for example, it will be automatically applied as this tooth. So therefore, you have really to pay attention where you place it. Okay, now you can do first tooth placement here. Most of you know the tooth placement. Left mouse is moving the teeth. Control and left is rotating the teeth. Shift and left mouse is scaling, and control and shift is scaling in one direction. Normally, if you just work in one jaw, I would recommend now to do the placement here and then to go to the next step. But you have also the possibility to click here, this feature, go to advanced placement, which means that you do the placement again later in a real tooth placement step, because actually we are still here in the copy tooth. Why is that? I would recommend to do that here because you are also working in the upper jaw simultaneously. And then we have the ability now in the next step to correct our placement in both jaws simultaneously. Yeah, okay, sorry. Then we can display again all the meshes. What I would do now, I would recommend to start with the lower jaw, and I will just place again my teeth in the lower jaw, just following the rules of dental technique, speak curve, and so on. Yeah, like that. And then I show again the upper jaw, or hide even the lower jaw, and I see my library teeth are maybe too small. Then first I scale the teeth a little bit here and place them approximately in the area of the preparation, like that. Yeah, and you see already here a color scale displayed on your teeth. That's quite important and interesting. What you see here is intersections with the antagonist. So which means you could actually work without your antagonist. You see directly where you have an intersection. Don't worry about the word intersection. It will be adapted later automatically. So with the occlusion. So, but then if you do the placement, you try to avoid having such huge pink areas, which means that you have a very deep intersection here in that area. Okay, now again, I will show also my lower jaw, and then I will try to do some corrections on both simultaneously. I think doesn't look that bad what I'm doing here. No. Yeah, you see the screw channels. I will hide them because I don't need them at all here during my design. Okay, like this. Perfect, I think. Great. This one is maybe a little bit too big. And yeah. Okay, and now it will be interesting. So when we are clicking and to the next step, no, it's coming later. Sorry for that. Now, first we do the emergence profile of our implant restorations. To do that, I would recommend to change the transparency of the jaw. I do that with Shift and the mouse wheel. You can change it back again, or with Control and the mouse wheel. You can hide an entire mesh, or with Control and Shift and the mouse wheel, you can bring it back. Yeah, so here for the emergence profile, you see that now the software has placed the emergence profile border following the line we have defined in the first step. And by default, those dots are sticked to the gingiva. And I can, by clicking on this point here, I can unstick them, and then I'm completely free in the placement of this point. So what you can do is also with Control and Shift, for example, unstick all the points and, for example, move all the points in all the areas. But now pay attention. Yeah, you can create big, let's say, big pressure to the gingiva if you don't pay attention here. Therefore, we have a nice feature here which allows you to visualize the distance above and below. Above means you have a gap between the gingiva and the emergence profile, and below means that you are below the gingiva, you create pressure. Then you can change the threshold of each, and I usually set it on the maximum because 0.3 millimeter of pressure on the gingiva, it's not enough. It's not much, sorry. And then you can move the entire emergence profile a little bit below the gingiva. This is very important if you do a custom abutment, because you don't want to see the cervical border of your crown later, which can be then above the gingiva. You want to have it below the gingiva. But in this case here, where we are doing screw retained crown, which is a monolithic crown, I can stay here, and I could even stick them back to the gingiva. It was just to explain you how I would do it when I'm doing a custom abutment. You cannot only visualize the distance between the emergence profile and the gingiva, you can also limit it. So, for example, if you use those buttons, you see now that it has changed the shape of it completely. Now the software is trying to keep both thresholds, 0.3 millimeter of distance or pressure, when designing this emergence profile. That's also a very nice feature. Personally, what I do usually, I'm not afraid of creating pressure here. I usually use this button, which shapes the entire emergence profile, or which create a convex shape on the entire emergence profile. And then I use the lower slider here for the lower part of the emergence profile to create a concave area at the platform of the implant. That's how I usually quickly design emergence profiles. Then let's go to the next step. And the next step now will be the outer articulator. Yeah, you see it now. What is this? This is an add-on module. We know that you see now the movements here. We know that if you're doing an intraoral scan, you don't have any physical articulator. Therefore, we actually put now both jaws into a center position of a generic virtual articulator, and we do the movements: protrusion, retrusion, lateral protrusion, right and left, and those will be saved in the software. Yeah, now you see that the software is also automatically already adapting the cervical borders and automatically adapting the occlusion and proximal and pontic basal contacts of the entire restoration. Yeah, now we are already done. We could now already send this to the manufacturing. So you see, that's what I explained in the beginning. In the chairside cut, we are trying to automate processes. So back to the auto articulator, comparing this to the virtual articulator and the lab software, there you have a big choice of different articulators which you can find on the market currently. And there we really copy the dimensions of every articulator and the movements. So to make sure that if you have a scanner which is able to transfer the physical position into digital, to make sure that if you adapt the occlusion digitally, you will have exactly the same result later in your physical articulator, and you will not have any conflicts anymore in the occlusion when doing the movements. Here in the chair side, it's different. So you cannot choose any articulator. It's just a generic articulator with a center position. And if you use it, I really recommend to scan the entire arch, because otherwise the movement or the influence of the opposite teeth here on the movements will not be respected when doing the movements. So as I said, it's just a generic articulator. We do the movements. It's not exactly what is the situation or the movements in mouse by the patient. So I think the perfect solution here is then the jaw motion import. So there are devices on the market which can be used with exocad to import those records, and then you can exactly copy the movements of the patient. And this is the best solution to avoid any conflict in your occlusion. Okay, now you have seen the software has adapted all the contact points, even on the occlusion. So for example, if I hide the upper part, I see now blue areas here. Blue means we have a clearance of 0.2 millimeters. So we have decided to have a little offset here to make sure you don't have any problem or any manual rework later at the insertion of the restoration. So blue means that it's a contact with a clearance, and you can even change here in this window the color scale, which will be displayed here. But I wouldn't recommend to do that. It's perfect how it's set by default. Yeah, of course, now we can even do some freeforming. Most of you maybe know already the freeforming. You can freeform cusps, entire tooth parts, or entire teeth. That's maybe something some people still don't know. If you choose entire tooth, you have the same options as in the tooth placement. With control, you can again rotate the tooth. Let's use the panic button and undo, or scale the tooth while it's already adapted to the margin line. Yeah, be aware that if you are working now here in the freeform after the adaptation, again, you can create intersections as you see here. So every color starting with green to yellow and pink means you have an intersection, and pay attention, you have then to adapt again. To do that, different options. You could simply hit Control X, and in one click you do the occlusal, the approximal, and the basal adaptation, or you just click on the button, cut all intersection, or you can check the different adaptations and set them individually. Let's have a look at that. For example, pontic, okay, here's nothing special. But for the occlusion, for example, we have now different options here. We can choose between static and dynamic. Static means your articulator is just closed without any movement, and if you don't have the auto articulator module, you cannot even use the dynamic feature here. Dynamic means that all the movements which have been simulated by the articulator will be considered when doing the adaptation here in the occlusion. And you can then, of course, define which one you'd like to start, upper or lower, because mathematically it's not possible to adapt both in the same time. Okay, then for the approximal adaptation, there's a quite interesting feature which I'd like to show, which we had developed initially in the past for the chairside software. You see that here there's a new feature. It's also available since I think Matera or Valletta. I think since Valletta in the dental CAD. It's called blockout neighbor collision, and it's really a feature I like. It's perfect for the everyday job in your lab or in your dental office. So you see that the adjacencies will be blocked out virtually following the insertion direction of your restoration. And then later, the restoration, the approximal sides will be adapted to this virtual blockout. So you will not have any manual rework at the insertion of your restoration later. Okay, let's adapt again all the intersections here, as we have changed the restoration in the freeform step. You see another tab here in the work step, which is attachments. Makes no sense here on this job. There you can add any kind of attachments to your restoration. This will be explained in different videos on our YouTube channel. There you can find a lot of tutorials explaining all the steps and all the features here in detail. Let's go to the next step. Yeah, that's the very last step. Here we do define the connectors, and we have added with Valletta, I think, also a new connector, which is designed to be used for anatomical restorations. Okay, due to the situation we have here, maybe the connection area is too small. We get a warning from the software. In that case, we could do a manual connector and draw it manually, but I don't want to show that now, and let's ignore it, and let's go to the next step. Yeah, screw hole design can also be skipped here. This is very important. For example, if you put ceramic on your restoration, then you can use this tool to create a stop for your ceramic around the screw channel. Yeah, and that's now very interesting. This is the in-cut nesting tool. It's a little bit different than a CAM software. In a CAM software, normally you put your restoration into the blank, but here it's different. You have your restoration, and now you place the blank onto your restoration in order that the layering, for example, of the blank fits perfectly on the requirement of the color of your restoration. And second aspect is that you can check directly if the restoration fits into your blank. And now we choose the blank for our bridge. Yeah, you see here it's a layered zirconia blank, and then we can now move the blank. With control, we can rotate it, or we can even use the arrows to do that. Now you see the layering here. Yeah, if it's red, that means that you have, that your restoration is does not fit anymore into the blank. Yeah, like that maybe. Then you can change here again the color or the milling strategy, and here the holder of your blank. Yeah, then let's go to the other blanks for the two crowns. Yeah, let's take a smaller one, and you see, yeah, by default normally they are set already correctly by the software. What I forgot now is you can also change the position of the sprue. To do that, you click here and edit sprue, and then you can even change that position. By default, the sprue avoids a placement on the cavity. This can also be deactivated if you want. Then let's take the last one and place this one. Yeah, and then you can proceed to the last step. And here in the last step, now you could now directly go to the manufacturing. You simply click then here on proceed to production. Then the CAM software would be opened. The information of your in-cut nesting, so the information of the position in the blank, will be transferred to the CAM software. I cannot start it now because I have no machine here connected to my system. And then you just enter the lot number and material and position and nesting. All is already done. And directly the toolpath calculation will start. This might take some time. And then you click next and your machine will start running. As we are not able to show that now, if you still have 5 minutes, then I'd like to show you another option you have now. Once you've finished the restorations, you can now also create a model, because that's also a very important topic. If you're working with intraoral scans, you always would need a model. And we start a model creator, which is also an add-on module available also for the chairside version Matera. Yeah, we start by choosing the model type. So in fact, there are two different types. So we can choose a model without a plate. So it's just a flat model with a closed bottom. It can be hollow, and the dice can be detachable. Or we can choose a model with plate. For example, if you have a Baumann plate, and then you will section the model and create single parts which will be put onto the model plate. All the other configuration types here you see are pre-configurations to be used with your manufacturing device. Either if it's a mill or if it's a printer, you should always ask then your provider if he has such a pre-configuration for the model creator. Then you simply use that one. For example, you see here an extent and many other printers, Formlabs. If you use that, you should not have any problem with the fitting later. Okay, but I will just take the without plate demo here. Yeah, now we can place the model between the planes. So the planes visualize the bottom of each model, and you can even change the height of the models here by using the slider. Okay. Don't forget that you will have analogs here, so don't worry if you put it too low, the software will detect it later and ask you to correct the position. Then go to the next step. Here we can even choose other dies to be detachable, for example, an adjacencies to better check the contact points. So then let's say we want to make the tooth, oh yeah, something not, oh sorry, no, the tooth 24 detachable, just as an example. And then the software will ask you, where is this tooth? You just click on the tooth and the tooth will be extracted digitally like this. You can still do corrections here. And then we go to the next step. Yeah, so now the software will start creating the first model. So in this case, the upper jaw model. There are a lot of parameters which can be changed here. I don't want to go into detail here today because we don't have enough time. We are already too late, I see. Sorry for that. As I already said, if you have selected the correct pre-configuration plate in the beginning, you don't need to change anything here, but you are able to. On our exocad wiki page, you can find explanation of all the model creator parameters. I think end of next week, we will also publish a first tutorial on the model creator. You see, this operation might take some time, and that's in fact, there are just 2 or 3 operations in our software which take some time. Normally, the software is extremely fast and extremely robust, but here we have a couple of very complicated Boolean operations to be executed, and this is why it might take sometimes half a minute to create such a model. But you see already that we have created, the software started by creating the dies, and now it's calculating the model base. Yeah, so here it is. So we have created a hollow model, and yeah, you can see that we have pins here on our model, and this is now the upper jaw. Then let's go to the lower jaw, which will be a little bit different as it is an implant model. And here it's quite cool that this is also, since Valletta, you can add flexible gingiva masks, and you simply click on add and define an area which should be created as a separate part of the model, which can be printed in with flexible material. And then it will be detachable. Yeah, you simply define the area, then you run the model. The software will automatically detect which implants are surrounded by your flexible mask. In theory, I could also even create one for each implant. Actually, we had already the question to have the same feature for cement retained restoration, so to have a flexible gingiva around dies. That's not yet possible, but we are also working on such a solution. Yeah, again, the software is now calculating the entire model. You see it started here with the gingiva part, which is already done. What you see here is the hole which will be created in the model to place the model, the implant analog and the screw. So this is an analog with a thread, and then with a screw you can fix the analog into the model. So there are different ways of fixing an analog into the model. So I really like this one with the screw, and then you are really safe with the position of your implant. Yeah, let's wait a little bit. So I think we are almost done. Yeah, there it is. Yeah, that's now our model, our implant model. If I change transparency of my gingiva, you see what happens here. So this part can be removed later of the model. And then let's go to the next step. In the last step, we can add attachments to the model, support pins, for example, to find manually back the occlusion between both jaws, or we can even add some kind of fixing parts to fix it into special articulators for such digital models. There are a couple of systems already available on the market. One I like is here also this one, which allows you to print directly your articulator together with the model. And then you can place it onto the model like that. And it will be printed. And then before we finish, you can also add some text, and then you can add the text to the model, for example, the patient name. By default, the software will take the project name here. If you change it, then you can have your own name. You can even add a series of text fields on the model, on the upper and the lower jaw simultaneously if you want. And now in the last step, everything will be merged and saved and exported for the manufacturing of the model. Yeah, that's it. So actually the software will export now 1, 2, 3, 4, 5, 6 different STL files for every part of the model, which can then be used in the software for the printer or for milling. Yeah, that's our finished model with the restoration, and that's it. Spires, are you still there?